Okay, here is the last slide in the 3-1 notes. It says, let Q represent a mass of carbon-14 in grams, whose half-life is 5,730 years. The quantity present after T years is given by the equation Q equals 10 times 1/2 to the T over 5,730. So the first question says, what quantity is present at T equals 0 years? So that means we're plugging 0 in for T. So I get Q equals 10 times 1/2 to the 0 over 5,730. So 0 over 5,730 is 0. So 10 times 1/2 to the 0, well, is of course just 10, or 10 times 1, right? So there are 10 grams present at the beginning, right? So 10, that's kind of like the P, the principal value. Now it says, what quantity is present after 1,500 years? So I get Q equals 10 times 1/2 to the 1,500 divided by 5,730. Now, of course, this is not one that you can do by hand, nor should you try. So you do want to do this calculation. But remember, when you do the calculation, you got to make sure you put parentheses around the power. And it's important to at least think about what is happening. So it says it has a half-life of 5,700. So what does that mean? That means it takes 5,730 years for the original amount to become half of what it once was. So if we started with 10 grams and 1,500 years have elapsed, what's going to happen? Well, remember, if 5,730 years had elapsed, we would have 5 grams. So that means, obviously, when we do this calculation, we should have, well, obviously between 5 and 10 grams, but probably closer to 10 because 1,500 isn't that close to 5,730. So when we do the calculation, we would end up with 8.341 grams. So like I said, between 5 and 10, but closer to 10 because 1,500 is closer to 0 than to 5,730. All right, the last one says, estimate the time needed for 4 grams of the initial quantity to remain. So now that means that 4 is Q, and then I have 10 times 1/2 to the T over 5,730. And so now we're thinking, all right, well, what does T have to be? Well, T is going to have to be, well, larger than 5,730. Why? Well, because 4 is less than 5, right? 4 is less than half of 10. So then we can start plugging numbers in to see what works. So we can plug in, 6,000, 6,500, 7,000, right, and see which one gets us close. So if we plug in varying values, we get that T would be about 7,500. Or plugging in 7,500 gets us very close to 4 as our quantity. Now, we will be discussing later on in this chapter how we could solve this equation for T, but in order to do that, we need to learn a little bit more about something called logarithms, which brings us to section 3.2.